Hello, my name is Guy Mayeri. I'm the head of business development of IOSight, and I will present on the topic of utilizing data analytics for surface water quality monitoring and event response. I will share my screen. Okay, so as I mentioned, the topic is utilizing data analytics for surface water quality monitoring and event response, and we're going to focus on a specific experience we've had in that area, applying and implementing two of our key solutions, iGreen and iShed, and I hope you will enjoy the presentation. A little bit about IOSight, what we do. We are a leading provider of data management and analytics for the utility sector, mostly water and wastewater. Our team is comprised of engineers, software developers, and data scientists and algorithm experts with specific experience in the water and energy sectors. And we have over 100 installations around the world, and we've been around for over 10 years. So again, a lot of experience and proven solutions. Our clients include utilities and authorities across the various segments of water and wastewater, like water and wastewater facilities and utilities, desalination, and watersheds in the environment. And this is where we're going to focus actually on that segment, the watersheds and environment. And I will share with you mostly one interesting case study, the installation and project we've been doing with Mekorot, the Israeli national water company, protecting the Israeli northern watershed, the Sea of Galilee and Jordan River. This is an installation which has been around for over 3 years, since 2017. So quite a lot of track record there. And also a little bit about the project in Chicago, HTNL Chicago, the Chicago River project. About our solution suite, so we provide an integrated, what we call smart water suite, which includes iGreen, the core data management platform, and several expert modules, advanced analytics expert modules. We will focus today on one of them, iShed, which is specifically designated for real-time water quality monitoring in rivers and watersheds. Now, when we look at what does it mean, data-driven surface water quality monitoring, what I see is like 4 different components or elements or pillars, if you will. The first one is the data foundation. Before you start doing anything related to data analytics, you need to make sure you have the right data collected, cleaned, normalized, and then sometimes virtualized and modeled in the right way. So you have a good foundation to work with. Once you've done that, now you can start actually providing outputs, simple outputs like dashboards, reports, a map view, or other types of outputs before you even begin analyzing the data. You rely on the data as is, after, of course, it's been cleansed and modeled, but you haven't applied any sophisticated analytics. That's that's the next layer. Then you can move on to predictive analytics or advanced analytics. You do historical data analysis, anatomy and pathology, what we call kind of like find, patterns, trends, kind of like what is normal, what is not normal. And then you can move to the real-time anomaly detection, like prospectively on a real-time continuous basis of water quality, and also calculate or predict downstream propagation of contamination. So that's the third layer. The fourth layer or pillar is the prevention and response. It's more like the actions. So now that you have those insights, either driven by simple outputs or by analytics, what are you going to do with that? So rules-based event management, real-time alerts, task management, response task management, all of that is part of the kind of like the operational layer of what I call, again, the data-driven surface water quality monitoring system. And today I'll speak about all of those four components and how they're kind of like intertwined and work together in our solutions, in our experience, specifically in the Jordan River Sea of Galilee watershed. So what are we talking about, this example? This is the Sea of Galilee, for those of you who don't know, Lake Kinneret, and this is the Jordan River, which flows into the Sea of Galilee. There are several streams flowing into the Jordan River. This is a very sensitive and strategic asset of Israel, basically the only surface water source that we have in Israel. So obviously it is of high importance, and the government and Mekorot decided that it's worthwhile monitoring in real-time water quality in the Jordan River. So the first step was, and it was done by Mekorot, to install monitoring stations along the river and some of the streams flowing into the river. So this is like, there are several monitoring stations installed, started continuously collecting and recording data like pH, turbidity, and other types of indicators, and also some other types of data sources like laboratory sampling and auto sampling in each station, weather gauges, on-site observations, just putting everything into like one coherent platform of data management. So that was like the first step, arranging the data, making sure you collect the data. If you remember, there's this kind of like logos, I'm going to follow them throughout this presentation, the data foundation. So, or these icons, I mean. The next layer was actually to create those nice dashboards. Okay, so so what you can see here are you can see the dashboard of one of the monitoring station. So simple dashboards: pH, redox, EC, turbidity of real-time water quality data in that specific station, and also some auto sampler data here. So that's like the first step. You can see that. You can see if there's a specific issue with pH or with turbidity, you can see it immediately in real time. So that's the first layer, or the second layer. The first one was the data foundation. This is part of the second layer of the outputs, simple outputs, data as is, after it's been cleaned and modeled. Another example is you might want to have a look across several monitoring stations. The previous slide was one monitoring station. What you see here are several monitoring stations. So, so you can see, for example, turbidity and redox across several monitoring stations during like a period of 1 month. So that's the second type of visualization you have across several stations. Now, the problem with this simple visualization or simple data collection at specific values like pH, EC, turbidity was that we started getting, or the client started getting, a lot of alerts. Like you can see those spikes here. There's a lot of spikes, and these cause alerts. And are these real alerts, false alerts? The Jordan River is a busy, not very large one, but a very busy river. There are all sorts of activities there, like rafting and boats going by, and all sorts of touristic activities. Turbidity could just suddenly rise because of that, and events like that can happen and trigger events, trigger alerts which are not real. And each alert, obviously, it's kind of like it begins a chain of reaction. You need to respond, you need to check, you start spending resources, money, and responding. And in many cases, in most cases, these were false alerts. There was a reason. So that was a key challenge in just looking at the data as is. So together with Mekorot, we developed the iShed solution, the iShed algorithm. Basically, what we're doing is continuously converting raw water quality data into what we call the integrated water quality index. So you take the data from the monitoring stations, you apply all sorts of data analytic techniques, which I'm not going to get into right now, and then you generate the integrated water quality index. So it's a 24/7 generation of water quality indexes across the monitoring stations, basically eliminating 95% of the false alerts just by applying these analytics. That's kind of like the bottom line. You made the system from something which generates a lot of noise to something which is something which is operational and you can work with and critical. The first step actually in establishing this kind of like data analytics solution of iShed is to develop the baseline. So for each monitoring station, there's the anatomy and pathology that I mentioned. Look at the historical data and define what normal looks like, what does an event look like for each of the sensors, and include all sorts of other types of data like the laboratory and auto sampling. So we created what we call the passport, the monitoring station passport for each station. So that was like the first step. Then, as I previously showed, we started generating the continuous water quality indexes. So for each station, what you see here is a mobile view. There's also a mobile view. There's very simple: green, yellow, red. If the index, the integrated index, which is again a combination based on data analytics of all the various factors, the pH, EC, turbidity, and so forth. If the index is in the green, everything is okay. If it's in the red, there is a yellow, like a warning. This is a yellow area. If it's in the yellow. If it's in the red, there's a red alert. Obviously, there's a flag and something needs to be done. Okay, so this is like a combination of, like I said, visualization, nice visualization tools, but also this analytics capability of generating the water quality index continuously. So this is moving already to the third pillar that I mentioned, the predictive analytics. The next, if you look here, for example, what you see is the dashboard of the total index for that specific station. So you can see here, this is, for example, at that specific time, everything is normal. The other thing that you see here are the adjustable weights. So it is also another way to make sure that you know, if you have a problem, you can neutralize that, a problem with data quality, let's say, or like the one that I mentioned before, with turbidity, for example. You can mute that. So you can decide, okay, I want to mute the turbidity data, and then the index kind of like ignores that. Or you can decide, I want to give different weights, like turbidity actually has more weight than the other water quality indicators. So you give it a 1.5 versus 1 for the others. So this is another way to adjust the data and make sure that the outcome that you get, the water quality index, is the most reliable one that you can trust. Another visualization tool is the map view. So for each of the monitoring station, you can actually see what's going on a map. So here there's one specific monitoring station, and you can see there's the specific water quality indicators, but also the index itself, the total index. So you can actually, again, combine visualization with the smart, like sophisticated analytics outcome and put it all in one place. So again, another nice way to look at what's going on at a specific monitoring station right now on the map. But not everybody's looking at their dashboards all the time. So there are other ways to get like insights and work with the system as like a nerve center for water quality monitoring in the river. So what you see now is it's a kind of like maybe it looks a bit awkward, but it's a very sophisticated report. What you see here are 3 monitoring stations, and for each day, and actually these reports are distributed daily and half daily for each of the monitoring stations, and you see, like for each of the monitoring stations, for each of the sensors, what's going on. Okay, you see if there's a problem with the specific turbidity or redox or EC. Here you see that for EC, it's in the yellow area. The specific index related to the EC before the integrated index is in the yellow area, because 2 of the values, which are like there are 3 different values that are being measured here. So the min, median, and max. So 2 of them are like in the yellow. And the same here for redox in that station. Here you have one in the red, and here actually what you see, the purple one, is actually an indication that there might be some issue with sensor calibration, because there's not enough variation between those values that might indicate a problem in sensor calibration. So these smart reports that you get first thing in the morning and sometime in the afternoon already tell you, like, okay, where should I be focusing today? You get that plus those water quality indexes for the previous 24 hours for all the stations. So again, you know what's kind of like my day is going to look like, or half day, the next 3 hours. Where should my attention be, and what should I be doing? Should I worry about sensor calibration? Should I worry about checking this monitoring station and see why this is in the red, the pH? So daily and half daily reports. Another way to combine the analytics and visualization. Now we're moving to the fourth layer, which is the operational one, the event management and response. So in this specific case, and generally, we're using the rules-based event management system. So we have a rules engine in which you can define rules on the specific tags that are in the system. So all the what you can see here is the system tree. All the tags are all the data points, basically, all the sensors for each monitoring stations, as well as the indexes, which are the calculation, the outcomes of the algorithms, are stored here. So here, actually the object of this rule is the index, the outcome of the analytics, and this rules engine basically defines warning limits, upper warning and critical limits based on the values, here is 5 and 7.5 for the index, and what is the trigger which triggers that. It could be a single exception or an exception during a certain amount of time, and what is the severity of the event, and so forth. Like, it really define a rule which is being triggered by the value of the water quality index in that specific station. So if it's yellow, then there's a warning alert. If it's red, if it's above 5, that's the warning alert, and then something happens. And if it's above 7.5, there's a critical alert, and again, something happens. And all the events are managed in this event management screen. Now, what happens when an event is being triggered? Several things happen. First of all, by the way, you can also see that specific event on a map. So here, for example, you can see the tag name, total index near, the unit name, sorry, that's in Hebrew, but and then you can see what is the value, the date, and where is the event. So you can track the event on the map. So that's another thing. But what happens when an event occurs, when there's a deviation? So this is like a yellow one. Okay, so an email, okay, is being sent to someone. Here it's like an email that I sent to myself for this demonstration purposes. So this email tells you, okay, there's an index exception, there's a water quality exception, and where is it, and what is the value of the exception, and what is the limit. So here we're talking about the upper warning limit. So and you see there's an attachment to it. That's the report. So you get a report which looks back at the data and actually shows you what really happened. So you can look at it and say, okay, serious event, not serious event. Here it's in the yellow. Okay, so the event is there and you can respond to it. Again, I go back to the fact that it's not the raw data. It's not the raw, EC, pH, turbidity. It's the index. So it's already validated as an event. Now, the fact that there's an event doesn't necessarily mean that there's a big contamination problem, but it does mean that there's something that needs consideration and attention. So that's the another part of the operational layer, what I'm kind of like marking here in this like clock. So it's a combination of the analytics of the water quality index, okay, and the operational layer, the response layer. Now, when an event occurs, let's say here you can see there's a red red dot or red point. So you know that the event happened here in this specific station. Now, let's say you have an intake plane somewhere down here or anything else. You want to know how fast and what is coming down your way. So that's when the second algorithm comes to play. Until now, we had the anomaly detection. Now we have the event, the contamination propagation calculation, which kind of like is being triggered. So as soon as an event happens, a real event, so the second algorithm comes to play, and there's a calculation of the downstream propagation to each of the downstream stations, as you can see here. So if, for example, you have an intake plant here, water intake plant, you can respond accordingly. Maybe change the chemical composition of the treatment, or maybe shut it down if necessary. So this is another element of the response to the event. Another element of the response layer is the ability to manage tasks remotely. So you can, for example, you can manage a maintenance task, let's say sensor calibration. You need to kind of calibrate a sensor. So you just use it using a mobile interface. This is the mobile interface for managing the test. You can also report something if you see like reporting a breakdown. So there's a lot of mobile/manual support in this operational layer. One of the things we've been doing in this project of the Jordan River is using a mobile for muting the algorithm when maintenance activities occur. So before that, a technician or a maintenance guy would get into the monitoring station and start, calibrating the sensors, and obviously causing a lot of values that, again, might trigger false alerts. Now what happens is that when the maintenance guy enters the station, before that he's kind of like logging in, and then the algorithm is being muted, and then as soon as going out, the algorithm is again going back to play. So what you can see here is this is the area where in which the algorithm is being muted because there's maintenance activity going on there. To summarize this, the key pillars of data-driven surface water quality monitoring. The data foundation, putting everything in one tree like we've done, all the data, the system tree, so that. The second one, making sure you have clean data, the right data, basically. The second one is the output layer, the outputs, the dashboards, the reports, and all these things. The third one is the predictive analytics, like the water quality index and the downstream propagation calculations. And the fourth one is the prevention and response. As you can see, they're all kind of like working together, like they're intertwined. And that's the beauty of the iShed solution for surface water quality monitoring. And that's why it's successful. And to summarize the case study, and sorry about a lot of text here, before that there was a lot of work, a lot of labor, limited ability to prioritize when sensors need to calibrate it or not. Obviously a lot of false alerts, which cause a lot of unnecessary response, which costs money and efforts, and you stop believing in the system. That's the low level of confidence, because there's too many alerts, cry wolf. And if there is something happening, a lengthy verification process. Now iShed, what iShed delivered was like a 500% productivity. Like half the people, you can manage many more stations. It's a 24/7 nerve center, continuously monitoring the watershed. You can prioritize your response actions when it comes to quality or sensor values. When there is something happening, you respond accordingly and in a timely manner. And if there is nothing to do, you kind of like basically reduce your unnecessary response action, which cost a lot of money and effort. There's a single source of truth and multi-layer compliance driven by this solution. Lastly, I want to speak about another project we've been doing over the last couple of years in Chicago. It's a completely different project. It's Current is the Water Cluster Water Innovation Hub in Chicago is the leader, and it's about real-time water quality monitoring, microbial water quality in the Chicago River. H2 Now Chicago is the name of the project. Data is being collected from diverse sources, from real-time monitoring stations called Proteus to other types of data. There's a lot of data being integrated. There's also a lot of partners in this case, and here it's actually about educating the public, informing the public when it's safe or not safe to interact with the river. So this is an ongoing project and still underway. iGreen is there, the visualization layer and the data collection layer, but the algorithm is still underway, still need to be developed. And there's others, obviously, there's very multiple other areas and opportunities we're looking at in the surface water quality monitoring space. So I thank you very much. I appreciate your time and happy to answer any questions, and my details are here. And that's it. Thank you.